Bismillah ar-Rahman ar-Rahim. Bismillah ar-Rahman ar-Rahim. It's my pleasure to share with you this my paper titled Internet of Things for Post-Disaster Recovery based on multi-informant. My name is Abdul Shaif. My paper ID 24. I am from University Malaya. The outline of my presentation is introduction, problem statement, objectives, methodology, results, conclusion, and future work and recommendations and references. Actually, in the introduction parts, I am highlighted of the natural disasters such as the floods and earthquakes, immediately impact of the telecommunication network infrastructure. The user device enter in the disaster zone are unable to access the cellular base station in the ground station. Therefore, we need the efficient way to establish the communication between the disconnection area and connection area. That's mean in the disaster area and non-disaster area. However, a lot of technologies include the satellite communication, mobility base station, and relay hubs used to solve this problem. Therefore, these studies have limitations to provide in the flexibility, low latency services, and swift adaptation to the environment during the natural disaster. What is the problem? The problem here happen when, due to the natural disaster, the infrastructure terrestrial communication networks damage. Then the user device enter in the disaster zone unable to connect of the cellular network due to the natural disaster. Therefore, the rescue teams need to communicate with the people inside of the disaster and outside of the disaster to save the life of the people in the disaster zone. What is the objective? The objective to provide in the reliable connectivity with low power consumption for post-disaster communication recovery, to help the rescue teams for researching enough information about the people enter in the disaster zone to save life, or to communicate with the people, how to secure or how to get these people is the safe mode. The methodology here, I use a mathematical model. The mathematical model including of the distance between the UAV in the sky and the ground user devices. After that, I calculate the probability of line of sight between the UAV and the user device, and non-line of sight between the device to device communication inside of the system zone. After that, I calculate the path loss including in the free space path loss, directly communicate with the user device, and extension path loss. This extension path loss due to the line of sight and low line of sight. After that, you calculate the coverage probability. The coverage probability including the for A and B, the coverage probability A for line of sight link and B for no line of sight link, and measure how to affect for the environment parameters can affect for the coverage probability of UAV to cover the disaster area. The system model here including the UAV in the sky and the half altitude and a lot of user device distributed in the disaster area. The problem happens when the base station is damaged due to the natural disaster. Then the user device communicate together by D2D by user residual energy, or I can get the wire surfaces coverage directly from the UAV in the sky. This for the figure 1. The figure 2, this one illustration location of the UAV in the height of 100 meters, and also distributed the users by 1 kilometers and 1 kilometers, and also the communicate the ring of coverage area of the UAV can see in the figure. Also, the communicate between the device-to-device communication in the disaster area to get the efficient link or the reliable connectivity during in the disaster. The outcome result here in the figure 3. In the figure 3, show the probability line of sight with the elevation angle of the user device. When the elevation angle of the device is increased, the probability line of sight is increased. So on. With on the environmental parameters such like the suburban area and the urban area and this urban high-rise urban. Then increase the property line of sight for the suburban due to in this obstacles area. No any obstacles area, this open area. The communicate of line of sight is more strong, and after that the urban area is in the second priority for the communicate. After that, the last one is the high-rise urban area due to the a lot of density of the building can affect for the user device to communicate with the affect for the UIF to communicate with the user device, and a lot of obstacles can facing for the line of sight communication with the user device. The figure 2 is confers for the figure 1 is no line of sight. This communicate between D2D communication in disaster area. All communicate any user device can get the wireless services not direct with the UIV and direct with the UIV can reflected from any segment in the disaster area to get the property line of sight. In this case, the high-rise urban is better coverage property. Why? It's more obstacles and more non-line of sight, our strong non-line of sight communication in this case. For this figure or figure 4, analysis of the path loss versus of the user defined distance. Increase the path loss, that means increase the distance for the coverage area between the UIV and user devices in the disaster area. But here in the suburban area, I see low path loss. Why the low path loss? This open area, a line of sight is more strong. The non-line of sight, I think 0. No any obstacles effective for the user device in this area, or for the high risk urban or for the high risk urban is more path loss, or the path loss is very high due to in the obstacles or due to the density, high density for the building in the disaster area. This effect for the UIV can cover for the disaster area, or can the user device has difficulties to get the wireless services coverage. This figure or figure 6 illustrates an analysis of the coverage property versus in the user device. Increase the coverage property by increase the user device distance. I mean the distance between the user device when it's distributed randomly in the disaster area. But I see the coverage property of the high-risk urban is more efficient or more increased better than the urban and disurban and suburban due to more obstacles. That means when we are calculating the coverage property including line of sight link and non-line of sight link, increase the line of sight link in the high-risk urban. This effective to increase the coverage property. That means the user device can get the wireless coverage area by direct communicate with the UIV or by non-line of sight by reflected signals from any segment in the disaster area. That means the suburban area is low coverage property due to only line of sight can get for the coverage surfaces due to this open area, no any obstacles, no line of sight. I think is 0. That means density of the building or the high-risk urban get more coverage property due to the reflected signals in this area for the user device angle and affected by the environmental parameters. Here, the conclusion deployment of the UIV to provide the emergency coverage in the disaster area and visibility for communication when the infrastructure is damaged. UIV are considered as the efficient system to provide the wireless during international disaster. The performance of coverage property drive within the selective environment, urban, suburban, disurban, and high-risk urban. The UIV network parameters such as elevation angle and UIV altitude is studied with environment parameters situations such as urban, suburban, urban, and disurban, and then we can evaluate it or check what is the parameters this effective for this. What is this parameters in the UIV can affect in the parameters of parameters of the environment to get in the better coverage during in the disaster area. This is a future work. This is a future work and recommendations. The researchers recommends to use the energy harvesting techniques with clustering and multi-hop communication for prolonging the lifetime or the sign stability of the lifetime of the energy and ensure the reliable connectivity during in the disaster phase. In addition, integrated the UAV with the UAV wireless covering with the smart device compatible with the Internet of Things and Internet of the Public Safety Things. Also in the matrix in the further investigation to get the efficient or to get the good coverage area in the disaster area or to resecure the people in the disaster area and save the life of the people. These references. Thank you so much. I am ready for any questions. Thank you for listening.